Hello everyone. In our previous video, we learned about the fundamental concepts of permutations and combinations and how they are used. In this video, by examining different scenarios, we'll take a closer look at them and see how they work in different situations. Imagine we have m balls and we want to put them in n uniquely numbered boxes, where the number of boxes, n, must be equal to or greater than the number of balls, m. Let's consider different conditions and find the ways we can do this. In the first scenario, the balls are different, and a maximum of one ball can be placed in each box. We want to find the probability of placing m balls in m specified boxes. In order to calculate probability of something, we must divide the number of favorable events by the total number of possible events. To find the probability we are searching for, the first step is finding the total number of possible events. For doing so, at first, we should separate m boxes from n existing boxes. That is, the number of permutations of n objects taken m at a time. After choosing m boxes, since balls are different, there are m factorial situations for arranging the balls in the boxes so that there is only one ball in each box. Now let's see what are the mentioned situations. Imagine we want to fill the selected boxes in sequence. Starting with the box number 1, for this box, there are m options because each one of m balls can be placed in the box. Now for the second box, there are less options because one ball has been placed in box number 1, so m minus 1 balls remain that can be placed in this box. And so on until the last box, where only the one remaining ball after filling previous boxes can be placed there. So the number of all possible cases to fill this m boxes is equal to m factorial. So in this scenario, to find the total number of possible events, we must multiply these two values. Then we should find the number of desirable events. The desirable event in this scenario is m balls being placed in m specified boxes. We can do this in m factorial ways, and that's because, as I just explained, there are m factorial conditions that boxes can be filled with the balls. So the total number of possible cases of the balls being placed in the boxes is equal to the number of permutations of n objects taken m at a time times m factorial. And the number of cases in which our desired event happens is equal to m factorial. As a result, the probability of placing m balls in m specified boxes is equal to the ratio of the number of our desired cases to the total number of possible cases. So the probability is 1 divided by the number of permutations of n objects taken m at a time. Now, imagine all the balls are the same. There is no difference between them, and the same as part A, a maximum of one ball can be placed in each box. And we want to find the probability of placing m balls in m specified boxes. Let's find how many ways there are to distribute the m same balls into the n boxes without any restrictions. I mean, what is the total number of possible events? There are m boxes, and a maximum of one ball can be placed in each box. On the other hand, balls are not different, so we should just choose m boxes from n boxes that can be calculated from this formula. Since the balls are the same, it doesn't matter if a random ball is placed in box number 1 or box number 2, because after all, the outcome is the same and they cannot be considered as different events. As you can see in these pictures, let's consider the condition that all m balls must go into m specified boxes. There's only one way to do this, since all the balls are going into specific boxes. Imagine we can see inside the boxes. In two different cases, we have placed balls in the boxes randomly, as we can see it is not important that which ball has been placed in which box, because they are all the same. As a result, the number of our desired events is just one, and that is m same balls being placed in m specified boxes. As a result, to find the probability we are searching for, we should divide the number of our desired events by the total number of possible cases. In the part A, the balls were not the same, so the two random combinations of balls in the specified boxes could count different. Now, imagine balls are different, and there is no limitation for the number of balls in each box. We want to find the probability of placing m balls in m specified boxes. In such questions that there is no limitation, analyzing the potential scenarios of filling each box with different numbers of balls can be difficult. Instead, it seems much easier if we try to find the possible ways for each ball to be placed in boxes. So let's find what are the options for each ball to be placed in boxes. Consider ball number 1. This ball can be placed in the box 1 or 2 or 3 to the box n. So it has n options. Now, consider the ball number 2, since there is no limitation for the number of balls in a box. This ball has an option as well as the first ball because it can be placed in the box 1 or 2 or 3 to the box n. In the same way, all of the balls have n options. So the total number of possible cases to place different balls into n boxes without any limitation on the number of balls that can be placed in each box is n to the power of m. Our desired event is the balls being placed in the m specified boxes. And since the balls are different, as I explained in part A, the number of our desired cases is m factorial. We can use this picture to remember how we came to this conclusion. As a result, to find the probability we are searching for, we should divide the number of our desired events by the total number of possible cases, as you can see here. We came to the end of this video. I hope that this video has provided valuable insights and expanded your knowledge.